I'm Steve Shepard, the director of the WSU Honeybee Research Program. I'm here with Sue Kobe and Tim Lawrence, and this video will be a presentation of techniques for practical selection and breeding of honeybees. Honeybees are fascinating animals to work with and essential to pollination of our food supply. Currently faced with many challenges, one of our most important tools for long-term sustainability and improved honeybee health is a program of selection for stock that is hardy, productive, winters well, and has a reduced susceptibility to pests and pathogens.
Beekeepers recognize the need for more rigorous programs to select, improve, and maintain their breeding stocks. The varroa mite and the movement of Africanized bees adds to this urgency. The principles discussed here serve as a guide to develop and establish a successful and practical breeding program with a focus on the traits you choose to enhance in your breeding population.
The basic prerequisites of a breeding program are: maintain a diverse population to provide a basis for selection, proficiency in queen and drone rearing, establishing selection index of desired traits, careful record keeping, control of pests and diseases, and a method to control the mating.
The honeybee colony is a superorganism and complicates the selection process. Keeping your breeding program simple is key. Genetic diversity within the colony as well as within the population increases honeybee fitness. Several mechanisms contribute to this diversity. One, the high mating frequency of the queen. A queen can mate with up to 60 drones, though typically mates with 15 to 20. Two, semen storage. After mating, only about 10% of the semen collected migrates into the spermatheca, although this represents each drone she has mated with. And three, the high rate of recombination, which produces new combinations of alleles to create genetic diversity different from both parents. This mating behavior seems risky and inefficient, though is very successful in creating a genetically diverse superorganism, the colony. The many subfamilies of worker bees represented by the different drones mated. Subfamilies specialize in different traits which together contribute to the colony fitness. The high rate of recombination provides the potential to test new genetic combinations that may increase resistance to pests and diseases and the ability to adapt to a changing environment.
Honeybees have a haploid-diploid sex determination system. Drones, or males, have one set of chromosomes, meaning they developed from unfertilized eggs. They have a mother, but no father. Workers and the queen are produced from fertilized eggs, thus they have both a mother and a father.
One of the challenges of honeybee breeding is that honeybees themselves are actually very sensitive to what's called inbreeding. And that's where a female mates with males that are closely related to her. In the case of honeybees, that leads to inviable brood. So one of the mechanisms for what we call outcrossing is the fact that the queen mates with multiple males. So if she mates with 20 males and one of them is closely related to her, that's not such a deleterious effect on the whole colony. In general, you have to be aware of the relatedness among all the bees that you're involved in a breeding program.
Honeybee breeding can be challenging because of these unique features that must be understood and considered in the development of a bee breeding program. An essential component of any breeding program is control of mating. Geographical isolation and drone saturation can be used and will provide partial control. Instrumental insemination provides complete control. However, this is a specialized skill and requires training.
With instrumental insemination, it's fairly easy because we can control the males that the queen mates with and we can make sure that they're not, from closely related lineages. But in the open mating or natural mating situation, you have to make sure that you have adequate genetic diversity in the mating yard. Another one of the differences in breeding honeybees is that the unit of selection for us really is the colony, because the colony itself, with all the different groups of workers and all the tasks that they undertake, is how we measure the quality and the viability of the sort of unit. You have to realize that that involves the genetics of the queen plus the 10 to 20 males that she's mated with. So it effectively makes a colony that's composed of a number of subfamilies, each fathered by a different drone honeybee. And the way that that unit works together is what gives you the traits that you use then for selection.
To ensure colony fitness, selection for a variety of traits such as productivity, temperament, overwintering ability, etc. must also be considered. Avoid selection for a single limited characteristic, such as hygienic behavior, VSH, or color.
Worldwide, the focus of many beekeepers is to increase resistance to varroa mites. Selection for resistance to varroa is complex and requires a suite of traits. Single trait selection programs such as varroa-sensitive hygiene or VSH and grooming behavior have value but are difficult to maintain, and these traits are highly variable. These traits can and should be selected and added to your breeding population. The goal must remain selection for overall high performance of the colonies in the breeding population. Your selection is a balance of maintaining genetic diversity and enhancing the fitness to increase the frequency of traits that contribute to resistance. In the selection of high colony performance, you may bring along traits for resistance of pests and pathogens, including some we have yet to identify.
Beekeepers and bee researchers have been selecting the honeybee for many years. Some of the earliest attempts included attempting to mate bees in a confined enclosure or by hand. Discoveries in the queen's anatomy and physiology led to the first breakthrough in controlled mating of honeybees with instrumental insemination. We owe a lot to some of the early pioneers in bee breeding like Laidlaw, Watson, Mackinson, Roberts, and many others.
We talked about genetic diversity, which is what you need as the raw material for artificial selection, for selecting bees. So you need that diversity. Yet within the stock that you're, say, trying to produce a large honey crop, you don't want bees that don't produce much honey. So you're trying to have certain traits in high frequency. That diversity is separate. That idea of diversity is separate from the idea of within colony diversity. So I mentioned that honeybee queens mate with multiple males. It's been shown that a colony where the different subfamilies within the colony are quite diverse is actually a much more stable colony, much more able to deal with stress and diseases than a colony that is fathered by, just say, several drones or drones that are very closely related. So intracolonial diversity, diversity within the colony, is a very good thing, and that's the reason that we seek to have a diverse drone pool and allow the queens to be well mated. Sometimes in poor weather, when mating is difficult, queens will come back and begin laying after mating with only several males, and in general those colonies aren't as viable as the ones where the queen fully mated with a diversity of males.
The Page-Laidlaw closed population breeding program is one of the most successful practical breeding systems used. The system basically is how most beekeepers approach selection. Choose the best and propagate from these. The key component is the annual selection program supported with controlled mating and record keeping. The success of the closed population breeding program is based on simple evaluation and selection criteria and a propagation program repeated annually. The goal is to maintain selection pressure on the population over time.
As new issues arise, new selection criteria can be added.
Beekeepers rely on natural selection pressure to increase desirable traits in the population. The goal of the closed population breeding program is to increase the selection pressure and the frequency of desirable traits in the breeding population. Given the behavioral complexity of honeybees, this can be challenging. To be successful and give the program longevity must be simple and repeatable. Honeybees respond to selection. We're just trying to enhance and speed up this process to increase general fitness. A successful, healthy, and productive colony has the traits we value, including reduced susceptibility to pests and diseases. As researchers discover and develop simple selection criteria, such as tests for hygienic behavior and grooming behavior, to reduce pests and diseases, these can be incorporated into the selection criteria. The effects of a changing environment and nutritional conditions must also be considered in the selection process.
One thing you have to realize when you're talking about breeding or selection for traits that you want, it's a balancing act between the fact that you need genetic diversity to have the raw material for selection, because you want to select, for example, bees that fight off disease, bees that are gentle, bees that produce a lot of honey, bees that overwinter well, a lot of traits that you really are trying to more or less fix or have occur in a high frequency in the population. And at the same time, you need to have the diversity to from which to select these things. So if you make the genetic pool too narrow, then you run into the problems of inbreeding that we talked about. Another thing to realize, especially when comparing bees from different locations, is that there are definite environmental effects. So you may have a colony that looks very strong and wonderful, and you say, oh, I'll breed from that colony, and then you make a lot of daughters and you put them in another location and they don't produce a lot of honey, and it's because, of course, the phenotype, or what you see in a colony, is a combination of the genotype of the bees, the genetics, plus the environmental interaction. So if you're in a very poor location, even if you have wonderful genetics, the colonies won't look very good. So for us, that's why we have to compare our genetic lines at the same locations.
There are many ways to accomplish stock selection. Our goal is to provide a practical starting point open to modifications that will serve your beekeeping operation and management system. With any breeding program, there are numerous steps requiring a keen sense of observation. A critical aspect is rearing high-quality and well-mated queens. Queen rearing methods will not be reviewed here, but note the basic requirements to produce high-quality queens that have been reared in optimal conditions. Drone production is critical and too often an overlooked aspect. To ensure a plentiful supply of mature drones from the desired stock takes some advanced planning. Drones are slow to develop and their peak maturity is 3 weeks post-emergence. Drones are also highly susceptible to stressors, pests and pathogens, chemical residues, poor nutrition, temperature extremes, etc. If conditions are not optimal, they disappear or are compromised. Older drones will be eliminated from the colony in favor of rearing a new batch of young drones for the future. So be sure drones are reared in strong, well-fed, healthy colonies.
One of the first things you need to do before starting a breeding program is to determine what are your goals and objectives. What do you want to achieve? What will your time and resources allow? You can start slowly with a limited number of colonies and build up, or you can jump right into it with a large and highly diverse population to select from. You may have generations of bees that you and your family have maintained, but you want to increase resistance or other valued traits in that population. Or perhaps you want to select a stock adapted to your microclimate in the forage you have locally. What do you want to improve and focus on? The more variables you include, the more difficulty achieving those objectives will be.
One of the most important considerations in a honeybee breeding program is the understanding that you're working with a population of bees, not just individuals. A colony may not express a desired trait because the frequency of this behavior is low. The goal is to increase the frequency of expression of several desired traits within the population and decrease the undesirable traits. This requires maintaining selection pressure on the population over time.
So what type of stock will you choose? Consider the various strains of bees and their characteristics, your beekeeping needs, and the climate. If you're in a northern climate, a strain adapted to long, cold winters and fast spring buildup may be preferred, such as the Carniolan or Caucasian bees. If in a temperate climate, a more broody strain that produces lots of bees for packages and nucleus colonies may be preferred, such as Italians. First, you want to establish a basic stock. Focus on a few general traits, such as productivity, wintry, gentle temperament, etc. Add a few specific traits, such as increased resistance to pests and diseases. Keep in mind the more variables you include in the selection criteria, the more labor-intensive and the slower the progress will be in achieving your goals and objectives.
Your objective should be to establish and maintain productive stock. Over time, in changing situations, you can begin to include selection for resistance to diseases and pests. For example, from within your population, test for hygienic behavior and select against colonies showing signs of disease, such as chalk brood and sac brood. Using the closed population system, pull your best colonies and select the best and graft a few queens from each of these. These virgins are then mated to the pool of select colonies to establish the foundation stock.
Establish a large population, about 200 colonies. From this base population of 200 hives, again, select the top performers based on basic traits. We call this the pre-selection test. You may initially screen that number down to the top 75 or more colonies. From these, select and further screen colonies, choosing the top 30 to 50 colonies as breeders, based on their productivity. From this selected group, produce a few queens from each of the top colonies and mate these virgin queens with a representative sample of drones from the selected pool of colonies. Here, instrumental insemination will give you the best overall results. Or use an isolated mating area. Produce about 200 queens, establish these in uniform nucleus colonies, and allow them to build up on their own populations. These then become the base stock for the following year's generation to select, and the process is repeated.
Using a large population will increase the life of your breeding program. Annually, new generations of queens are reared and mated to a known pool of selected drones and established in full-size colonies and evaluated in the field. A few exceptional rock-star selected breeders from previous years may also be included. This may help increase the frequency of valued traits and also longevity.
The success of your breeding program is dependent upon long-term commitment to rigorous evaluation and careful record keeping. If this effort is relaxed, the expression of selected traits and the productivity of the stock will revert to mediocrity. General overall productivity should be your main goal. This is often based on a complex of traits. Consider honey production and resistance to pests and diseases. Many traits contribute. It is not necessary and not practical to measure each contributing factor. Simply select for high general performance and low varroa levels. Choosing the top performing colonies allows us to select for the combination of characteristics responsible for high production without detailed and tedious measurements of numerous specific traits responsible. Environmental conditions and seasonal effects vary in different locations, and this needs to be considered so that colonies can be compared. Therefore, scoring should be adjusted to reflect these conditions and selection priorities. To ensure and extend the longevity of the program, a large base population is maintained, and occasionally new sources can be tested and added to enhance the gene pool. These sources must be subject to the same rigorous selection process before incorporation into the program. Care must be taken to add these slowly and cautiously and prevent major changes in the stock. If an undesirable trait is added inadvertently, this can be difficult to remove. To add new stock, set up a test yard and observe the performance of this stock and its combining ability with a foundation stock before this is added to the gene pool. Make reciprocal crosses and test these.
To expand the gene pool and avoid major changes in the performance of the foundation stock, seed in a few drones. This will enhance genetic diversity.
To observe genetic variability and effectively make selection based on this requires that the environmental factors and management practices be as uniform as possible. All colonies must be treated equally regardless of their performance. This is a comparison test. It is important that all colonies be evaluated or not managed differently. For example, colonies cannot be equalized or boosted with additional brood or bees. Colonies that do not meet the high standards for performance are simply weeded out of the program. We recommend a two-phase approach of selection be used. The first phase refers to pre-selection, is designed to evaluate the general performance. At this stage, the poor or mediocre colonies are cut from the program. The evaluation and scoring process is designed to be simple. The following protocol is a guideline. You may need to adjust point values and priorities to address your conditions and needs.
The pre-selection process consists of observing several traits at a given time and ranking each of these with a number point value. A point value system of 1 to 5 is used, 5 being the highest value. Choose a few key traits. We recommend selecting from 3 to 6 characteristics in your test population, such as brood viability, temperament, pollen hoarding, colony buildup, and color. A specific trait of concern can be weighted more heavily to give this priority attention. For example, if there is a concern the stock is defensive, a point value of 1 to 10 can be used to increase the selection pressure for this trait. Negative point values can be given for the low incidence of minor diseases and reflect the severity of this occurrence, or the colony is simply cut from the program. Scoring the occurrence of each valued trait. The point value of several traits is added and the sum of the total compared among colonies. Several traits are observed quickly and simultaneously, requiring only minutes per colony. Colonies should be evaluated on the same day by the same person to maintain consistency. If colonies are located in different apiaries, a yard average can be used to compare scores between these.
Selection for high brood viability is essential to maintain genetic integrity of the population. An estimate of brood viability is determined by observing the solidness of the cap brood pattern. Look at several frames, as one may appear spotty due to nectar or pollen in the brood nest during a flow. The bees should be calm and gentle regardless of the colony size and in most conditions. Temperament can also be noted during general hive manipulations. This will help eliminate the reaction to any disturbance that may have unknowingly occurred before evaluations. Color is one of the easiest traits to select for and a good marketing tool. With proper selection, your line will become more consistent in color. It can be an important first impression that beekeepers appreciate. Because drones are haploid, color is very easy to select with controlled mating. If selecting within a specific subspecies, queens producing daughters with unacceptable coloration should not be used as breeders. This indicates mismating.
At this point in the pre-selection phase, evaluate where you are in the overall selection process before going on to the next phase, where you look at industry and productivity and more specific traits. Make a cut and eliminate the mediocre and poor colonies. The pre-selection colony score sheet allows you to compare and choose the best performing colonies. Based on criteria we have evaluated so far, each colony should have a score of up to 25 points. Set a cutoff point, say all colonies with a score of 20 or above. These are taken to an historically good honey-producing location to test productivity.
The second phase of selection is the weight gain test, indicating colony industry. Colonies scoring average or above based on their fall and spring pre-selection tests are given a weight gain test. Colonies are tested during the honey flow in late spring or summer, dependent upon flow conditions.
The amount of weight gain over a short term, a few days to a 1 week period, correlates how the colony will do over an entire season. We are estimating the initial colony weight, and then we will come back in a week and take the second weight to determine the gain over this time period. Rather than trying to pick up the whole colony, which can be rather awkward and clumsy, we take the weight on the front of the hive and the weight on the back of the hive. Then add these two weights together, and this gives you the weight gain. We can now compare the weight gain between colonies.
When establishing a test yard, care should be taken to minimize drift. Place colonies in an irregular pattern or face colonies in different directions, or color code the entrances to minimize drift.
After selecting the top performers for general traits and productivity, we can also look for specific traits, such as tests for behaviors that will reduce the severity of pests and diseases. There's a high cost to single trait selection, as this greatly reduces genetic diversity, which we know is essential for colony fitness. So it's important to first select for productive colonies, then add selection to increase the frequency of specific traits we know contribute to resistance to pests and diseases.
One of the earliest examples of selection for behavioral trait was the work of Dr. Rothenbuehler's hygienic behavior test for uncapping and removing dead pupa. This selects for olfactory sensitivity and is now a test most queen producers demand in their stock. It is an important tool to reduce the incidence of brood disease. It is a common trait found in all colonies, but often only expressed in about 10 to 20% of the honeybee populations. With selection, the frequency of this trait can be increased. To be hygienic, a high percentage of the bees in the colony must carry this trait. During a honey flow, or when the large emergence of young nurse bees, colonies will appear more hygienic compared to a different time. Only colonies consistently displaying this trait will be considered hygienic. Testing for varroa levels can be accomplished in several ways. A mite roll is an easy, common test, though consider the time of the year and the climate to establish a threshold. Mite rolls should be taken several times a year. Mites vector pathogens and at high levels compromise colonies. Harmful viruses can persist for long periods of time after mite levels have been controlled. A top-performing queen in a heavily infested colony will not thrive. A final colony ranking is made and breeders selected to establish the next generation.
The closed population breeding program is designed to be a simple, practical, flexible, and effective method of selection within a known honeybee population. It is designed to increase the quality and consistency of valued traits in the population. It is closed in the sense of controlling the introduction of unwanted stock, yet it allows the controlled addition of new material to extend the life of the program. The key is the annual evaluation and selection program to maintain selection pressure on the population over time. Keeping this simple is important as this helps to get the workload accomplished.
So in summary, what we've demonstrated here is a simple, pragmatic approach that beekeepers can follow for selection and breeding of honeybees. We've gone through phase 1 where we've looked for characteristics such as temperament, hygienic behavior, color, brood viability, and from that population that demonstrates the highest frequency of those characteristics, we've looked for those that are the most productive bees. In other words, those that produce the most honey. So remember, we're selecting from a population of honeybees that demonstrates desirable traits and is productive. We encourage you to adapt this program to meet your needs as we all look for sustainable solutions to honeybee health.
We hope this video has been informative and you can adapt these techniques to improve your own breeding program. It's worked well for decades for the New World Corniolan and also the Washington State University program queens.
So thanks very much for your attention and happy bee breeding.